Hello everyone. Today we are going to discuss about security constraint, optimal power flow. Today's topic is security constraints, optimal power flow. To analyze this topic, we are going to divide the security levels into four categories. In that, first one is optimal dispatch. Second one is post contingency. Third one is secure dispatch, and last one is secure post contingency. Before we move on to the actual four states, we need to know what is constraint and what is contingency. Constraints are nothing but the conditions that we are going to impose before considering any events, and contingency we call it as an event or a fault that may occur, may not occur. Remember, contingency is an event or a fault which may occur or may not occur, and we cannot predict it certainly. Okay, remember, it's a merely fault in the future. We can't assure and we cannot predict it. And constraint is a condition. Basically, we can call it as a unnatural way of approaching constraint. Okay, let us move on to the actual four states now. First one is optimal dispatch. To analyze these four states, let us consider an example. Here is our example. We are having a to supply with a load. Okay, first generator is supplying 900 megawatt, second one is supplying 300 megawatt, and our total load is 1200 megawatt. Load is near to our second generator. Okay, 900 plus 300 is a total generation of 1200 megawatt. We are having a load of 1200 megawatt. Okay, and 900 megawatt is equally distributed here, 300, 300 and 300. Okay, this is the state, okay, where we call it as economically optimal state. Okay, this state may not be secure. Remember, this state of operation may not be secure, but it is economically optimal. Okay, minimum cost, maximum power transfer. And remember, we are not talking about any contingency, which means any fault has occurred at. This is called as optimal dispatch. When we are having a generation and load is supplied with the economically optimal way of transferring power. This is the state of optimal dispatch. If the same state is affected with the contingency, okay, that will be our second state, which is called as a post contingency. And in post contingency, here we can see there is a fault in one line because of overloading, or maybe because of some other issue, contingency. Here we are having a post contingency, means after the contingency has occurred, which means the fault has occurred here. This state is a state after a contingency has occurred. This may lead to a non-secure state. Remember, this state may lead to a non-secure state where there is a violation of a line power flow. Line power flow has violated, and voltage, current, this has been exceeded in the line. Here you can see, since there is a fault in the third line, the first and second line are overloaded. Previously it was 300 megawatt, now it is 450 megawatt. Here we can see the violation of the line power flow. Previously economically optimal supply was 300 megawatt. Now it has been exceeded to 450 megawatt. 150 megawatt has been excess to each line. This is the case where we call it as a post contingency. Two lines are overloaded. Okay. To overcome this, when two lines are overloaded, we need to make sure these two lines are not been overloaded. Now we need to clear this fault, and we need to make sure each line is carrying equal power. That state we call it as secure dispatch. Third state. Here we can see, now we have redefined our generators generating capacities. The load is same, 1200 megawatt. Previously the generating capacity of first generator was 900 megawatt. Now it is 600 megawatt, and second generator is 600 megawatt. Previously it was 300 megawatt. Now we redefined the two generators generating capacity, and now the transmission line is carrying 200 megawatt each. Since it is 600 megawatt, we need to transfer 600 megawatt from first bus to second one, and now we are having 200 megawatt each. The economically optimal case was, remember, we can say it as 300 megawatt. Now the line are carrying less than 300 megawatt. Now they are not overloaded. You can see there are no contingency here yet. So each are carrying 200 megawatt. The system is secure. This is the state where there are no contingency, but operating parameters are corrected here. The operating parameters are corrected. Previously it was 900 and 600, 300. Now it is 600 and 600. We have corrected the operating parameters. And just to make sure the security violations are minimized. Okay, there is no fault. And our last state is secure post contingency. We have secured the system in the previous state. What if the contingency occurs even after the secure? This is called as a secure post contingency. Here we can see 600 megawatt, 600 megawatt, which is the state of a secure dispatch. Load is 1200 megawatt. Again the same contingency has occurred, which means there is a fault in the third line. Now we got loaded to first and second line. Previously it was 200 and 200. Third line was carrying 200. That 200 megawatt is loaded to first and second line now, 100 each. Now we are having a 300 megawatt each for the other two lines, and which is economical as per our first case, optimal dispatch case. Yes, here we can see in optimal dispatch we are having 300 and 300 megawatt, and now we are having 300 and 300 megawatt. Yes, there is no violation of the line power flow. We are having maximum of 300 megawatt. This is the state where the system is secure after a contingency. Even the contingency has occurred, the system is secure because there hasn't been any violations of the line flows. Voltage or power flow has not been violated. It is fixed to 300 megawatt only. Okay, here the security corrections are already applied. We can see security corrections are applied. Previously it was 900 and to 300. Now it is 600 and 600. Since it is 600 and 600, the line is carrying 300 and 300 each even after the fault has occurred. Okay, this is about secure post contingency. This is all about our topic today, security constrained optimal power flow. If you have any doubts, please do text me or message on my Dropbox. I'll surely reply. Thank you.